Hello everyone, so today in this video we are going to solve a question of LeetCode that is construct binary tree from pre-order and order traversal. This is the 105th question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given the two integer arrays, first is the pre-order and second is the in-order, where the pre-order is a pre-order traversal of a binary tree and in-order is an in-order traversal of the same tree. So basically we have given the pre-order traversal and the in-order traversal in an integer array of a same tree. Like this is the in-order and pre-order traversal of a same tree. Now what we need to do is we need to construct and return the binary tree. So we need to construct a binary tree from this given pre-order and in-order traversal. So let's just see the first example. Let me just copy it from here to paste it here. Right, so this is our first example. Let's just make it white. Alright, so this is our first example. Right, so what we can do is let's first understand what is pre-order and order traversal. So pre-order traversal is basically representing the elements of an binary tree in a form like root will appear first, right? Root will appear first, then left element, then the right element, right? This is the sequence or the order of elements in which a pre-order is arranged, right? And in the in order, first the left elements will come, then root will come, right? And then right elements will come, right? This is the order of in order traversal, right? So what we can see whenever we find out any elements, right? When let's say this is a root, so the elements will always be the same, right? So this root is here, let's say this root is here and we find this root is here, right? So what we can do is when we find out this root, then this root must be equal to this root, right? When this root must be equal to this root, then we can easily find out the left and right elements, right? And this will help us to easily construct the tree. So we will see this later in this video. Let's quickly see how can we start approaching this question, right? So what we can do is we can keep a pointer here, right? We can keep a pointer here because the initial element or the zeroth element is the root. So what we can say is this root is the root of a binary tree, right? This is the parent root of a binary tree. So what we can do is we can make this root as a parent node or the initial node, right? So this is 3, right? And we can keep a left pointer here in the zeroth index and right pointer here, right? Now what we can do whenever we get this root, right? This is root. So whenever we get this root, we can search for the similar root in this in order. So we get 3 here, right? 3 is the root. Now these both are same. These both are same. So what we can say is, let's say we keep is as a pivot point, right? So what we can conclude here is this is the left part and this is the right part of the binary tree, right? As per this rule of in order, this is the left part and this is the right part of this binary tree if this 3 is the root, right? So let's say this is root, right? Because we already know from pre-order traversal. So what we can do is we can run the recursive call for left one and the recursive call for right one, and recursively we can form this tree, right? So let's quickly see what are the next steps. So in the next step we first check for the left one, then for the right one, because as per the pre-order traversal we will get the left then right, right? So what we will do, we will first check the left one, then we will check the right one. So let's move the pointer. This is 3, we just checked for 3. Now we come to 9, right? We come to 9. Now for this 9, let me just rub it first. Now for this 9, what we will do, we are first checking the left part, right? We are checking the left part. This is the left part. So for this left part, in this part we only have 9 and 9 is the root as per this rule, right? We always keep this pointer at root of this node. So we come at left part and in the left part we get a root 9. So let's make 9 as a node here, right? And we don't have any left and right part here, so we will just return from here to 3, right? Now yeah, so we have just completed the iteration of 9 here, and we don't have any left and right here. So let's move to the right part of this in order traversal, and let's move the pointer to 20, right? Now for 20 we are basically checking for this window 15 to 7, right? We have already checked for 9 and 3, so we are now checking for 15 to 7, right? So for this 20, let's search 20 in this part, right? So 20 is at this point. Now let's keep this as pivot point, and our left pointer is here, right? This is not valid. Now this is the left pointer, this is the right one, and this is the pivot point. So what we will do, we will make the right part of this tree, right? Because we return from here, and this is the right part. So for this right part we have root 20. Let's put 20 here, right? This is 20. Now for this 20 we have left part here. This is the left part, right? This is the left part, and this is the right part, right? This is the right part, and this is the left part. So for left part, let's see, this is 15, right? So for 15 the left part is a root, so 15 is a root for the left part, and for the right part we have 7. For the right part we have 7. 7 is the root. So what we can do is, for the each recursive call we will get a new pivot point and left and right as the window, and we will recursively form this tree. I hope the approach is clear to you. It is little bit complex, but if you try to understand this by code, you will easily understand the approach, right? So let's quickly move to the coding part. If you still have any doubt in this explanation, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So in the coding part, let's first take initial pointer int root index. This is initialized with 0 because we are taking the root index as this 0, right? Let's say this is a root index, so we are keeping this as 0. Now let's directly call a recursive function, or what we can say, we will forming a function here. So let's first make a function. So this will be returning a tree node. Tree node is basically a binary tree, and let's name it helper. In this helper we will be taking the pre-order vector and in-order traversal. So let's just copy it from here and paste it here. Other than this, we are taking this root index, so let me write root index here, and this is basically an integer value, so int root index, right? Other than this, what we are taking, we are taking this left point and the right point, right? So let's take two integers, int l and int r. This is basically defining the window of each iteration, or like we can say the each left and right part, right? So let's quickly make this l and r, and let's first see the boundary condition, right? So what are the boundary conditions? So we can only form the tree through in-order traversal when this L is under the range. So what is the range of this L and R? So until and unless, right, this L should be less than equal to R, right? If this L exceeds the R, then we cannot form this tree because we do not have any elements here, right? In this case, when L is greater than R. So let's just write it here, right? If L is greater than R, then in this case we will just return null from here, right? This is fine. Now let's take a pivot point here, right? We are in the each iteration, we are just finding out a pivot point, right, to find out the left and right part. So let's initialize a pivot point here. Pivot is equal to, let's initialize with left, and we will just update the value as per, like whenever this values will be same, right? So what we will do, we will make a pivot point initially as at L, right? And to find this value, we will run a while loop until this value is equal to this value, right? Whenever this value will be equal, so pivot point will be here, right? Pivot point will be here, so we will just stop it here. So pivot will be here, right? So let's just write this while loop here. So while pre-order, right? This is pre-order. So for this pre-order, we are taking the root index. So pre-order root index does not equal to, until and unless this is not equal, then we will just increment this pivot point, right? So when pre-order traversal root index is not equal to this one, right? So is not equal to in order pivot, we will just increment pivot point, right? And whenever we increment, we will get the pivot point here at the root, right? We will get the pivot point at root. So what we can do is we can just update this, right? We can just update this. So let's update it in tree. So let's make the new node. Tree node is equal to tree node new node, right? Let's make a new node for this is equal to new tree node, and let's initialize it with pre-order root index, and let's update this index, right? Let's update this index to next one. So let's increment this. So this will be incremented to root index plus plus, right? Now let's call the recursive call for left and right part, right? We are just checking the left and right part. Let's call the recursive call for this. So new node is basically our binary tree, right? Because we are just forming a binary tree here as a node. So new node left, the left part will be equal to, let's call helper, pre-order will be same, right? This will be same. We can also keep this as a reference node, right? Because this won't be changing for this recursive call, right? So pre-order, let's keep in order as it is, and this root node will also be as it is, root index, right? This root index will be as it is. Now let's see what will be the left and right value. So for this left, right, for this left, what we are doing, let me just rub this, right? So for this left, what we are doing, let's say this is the pivot point here, this is the pivot point. So for this left part, the left will be from L to P minus 1, right? And for this right, for this right, the pivot point will be from P plus 1 to R, right? This is the range of this pivot point. So for this left, this is L to P minus 1. So let me write it here. This should be L comma P minus 1, that is pivot. And for this right, so new node right is equal to helper pre-order, this will be in order, and root index will be as it is. Then the range would be, this L will become P plus 1 and R will remain as it is. So this should be P plus 1 and R will remain as it is, right? And at the end, just return this tree. So this should be new node, right? Now this is fine, I guess. This help function will be fine. Let's just return this function from here. So return helper, right? Let's pass pre-order in order, and then the third one is root index. So root index, let's write root index and L and R. So L is initially 0 and R is the rightmost one. So rightmost one is basically the size of in order minus 1. So let me write it here, in order dot size minus 1. Alright, this is fine. Let's just run it. Alright, we are getting a error here. Let me check. Alright, we just keep this as L. This should not be left, right. It should work fine now. Oops, still there is an error. Let me check. Alright, this is the syntax error here. Yeah, it is still an error. Let me check. This is right. Okay, this should be pivot. Yeah, this should work fine now. Yeah, it's working fine. So let's just submit this. Yeah, it's working fine. So the time complexity, right? The time complexity for this solution should be, let me write it here, time complexity is big O of n, because we are just traversing through all the n nodes, and the space complexity is also big O of n because the recursive call will take around big O of n space, right? So that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.